All right. So let's continue. The last slide, as I mentioned, I'm sharing to you some of the controversies of using Likert type data in path analysis. But I've also shared to you that there's a counter argument among social scientists and nursing scientists that our ability to measure is at its best already, and that we should never be paralyzed by the limitations of the different measures, but we should always try to continue to improve upon our existing measurement tools by refining our tools and by continuing to develop more accurate tools to measure psychological variables. All right, so this is path analysis in mathematics. It's really elegant and just fascinating. The notion of causation is implicit in path analysis, but because it is never possible to prove causation, there are some terminology here that's being used by the author of path analysis. And for example, when we discuss about association or prediction, we don't really mean that that's a cause and effect. The assumption of causation in path analysis is strengthened when we know that the observed and measurable relationship between independent variables, such as represented by X, and by an dependent variable is association. And it is strengthened when number two, when the independent variable precedes the dependent variable in time. So these are basically a repetition of the conditions of causation, because number two is what we call temporal ordering. And then number three, independent variable and dependent variable have a non-spurious relationship, and that the relationship between the independent and dependent variable will not disappear upon adjustment for other variables. So that's what you call, there's the absence of confounding variables, and that's what we call the third condition of causality, which is non-spuriousness. So this is a different slide, but I just want you to connect the dots right away. This is basically the three conditions of causality, or the three conditions of causation, cause and effect, and that there is observed and measurable relationship between independent and dependent variable. There's the temporal ordering, and then there's the non-spuriousness of the data that we collect. So when we use path analysis, it uses regression, but it goes beyond traditional regression analysis. It looks at association between independent variable and the dependent variable. As I mentioned, if you imagine education has a direct cause and effect to exercise, and beliefs also has a direct effect on exercise. So those two independent variable, beliefs and education, are distinct, and they have their own total effect on exercise. And then when we do path analysis, you also simultaneously look at independent variable and dependent variable having a non-spurious relationship, which means that there are no confounding variables, that there are no other variables that we missed in our measurement. So, can you guarantee that there are no confounding variables that you did not measure as a scientist? Not really. But that is the assumption of path analysis, that you have already theorized, you have already drawn the path of the relationship of the variables, and that you have already examined the existing science, that there are no other variables that you missed in the calculation of what leads to the dependent variable. So that is the assumption of path analysis, that the model is complete, that there are no confounding variables that you missed as a researcher. So it really requires a comprehensive literature review. It really requires a profound understanding of all independent variables that could potentially lead to the effect, which is the dependent variable. And because you already accounted all the independent variables, and because you've already examined the direct and indirect effects of each independent variable, and you have not missed any confounding variables, you truly have causality. So that is the assumption of path analysis. And to meet the temporal ordering requirement of causation, you need your design of your research study cannot be cross-sectional. This is such an important concept to remember. You cannot do path analysis if you collect your data in a cross-section design, which means you did not follow the patient longitudinally. You only get a snapshot. That's what cross-sectional. It's like, okay, I'm gonna give you a quality of life questionnaire after you have your transplant only at one time. Well, that is what you call cross-sectional. You capture their quality of life wherever they are in their post-transplant organ transplantation phase. You cannot do path analysis with a cross-sectional design. With path analysis, because it requires causality and because it implicitly requires the conditions of causation, then there has to be temporal ordering. And when you require temporal ordering, it requires a longitudinal research study design, which means that you have to follow or conduct a study, whether it's a 3-month period study, whether it's a 6-month period study, or whether it's a 1-year period study, and you collect data at several time points. And then the assumption is that X1 or independent variable precedes the dependent variable in time, which means that it has to happen at a certain period of time, whether it's at 2 months post-transplantation, whether it's at 3 months post-transplantation, but it needs to have that temporal ordering in order for us to conduct a path analysis. So recursive and non-recursive models, as I mentioned earlier, it's quite ironic that here in the textbook, they call recursive as one-way flow of causation in the model. But when I look at the dictionary and the thesaurus, recursive actually means circular. So, but it means the word recursive here in statistics, it actually means non-circular, that it cannot, it's only one-way flow, and that it cannot go back to where it came from. And that's what recursive is. So if you start with variable A, and then you have variable B, and then you have your variable C, You can't go back from C, go back to A again. The C is the terminal. That's the final destination of the path model. And that's what you call recursive. So in a non-recursive model, at least one of the paths between two variables is a two-way road, or there is a set of paths in the model that are circular. I had to grapple this in my mind because I said, why do they call this non-recursive? And then when I look at the definition, you know, we are Filipinos and English is our second language. So we try to dissect every single word, and it was like, this just doesn't make sense. But anyway, we had to follow the way how it's being described by the authors, and that recursive is one-way road, and it means non-circular in statistical term. And then in a non-recursive model, in statistical terms, means that it is circular. So I can't argue with this because clearly the author of statistics seems to use the word, I hate to say the word incorrectly because perhaps it's just us, it's just me, because English is my second language and I look at literal meaning of recursive. And when I look at thesaurus, the meaning of recursive means circular. And then here it's being described as non-circular. So, all right. So the indirect and direct effects is the highlight of path analysis. This is one of the questions, one of the research questions that is being answered by path analysis. It looks at the direct and indirect effects of independent variables, 2, 3 independent variables, and then it calculates its total effect. So what is the direct effect? These are those that are reflected by one direct line between the independent variable and the dependent variable that points toward the dependent variable. And then what are the indirects? Well, these are reflected by a line from the independent variable to the dependent variable with another independent variable in between, and no direct arrows. So that's what you call the indirect. And then in path analysis, it is additive. It calculates both direct and the indirect to give us the total effect. So endogenous and exogenous variables are the terminology that we use when we talk about path analysis. To do path analysis, we need to perform a separate regression analysis for each endogenous variable in the model. And what does endogenous means? Well, dependent variables are always endogenous variables. So these are our outcome variables. What we call the dependent variable are always endogenous. But some independent, or what we call the predictor variables, can be endogenous if they are themselves being influenced by another independent variable. So they can be called endogenous variable. Our independent or predictor variables can be called endogenous if they themselves are influenced by another independent variables in the model. So what about exogenous variables? These are variables that are not influenced by any other variables in the model, and they have no arrows pointing toward them. That's what they can only be independent variables. So that's what we call the exogenous variables. So the path coefficients, I've mentioned that we always remember the correlation coefficients and think about the strength and magnitude of the relationship, of the linear relationship. And once we start seeing a correlation coefficient of 0.4, and higher, then you know that strength and magnitude of the relationship is getting stronger and stronger. So that's a point of reference when we do path analysis. The subscript used in the notation for path coefficients are ordered in such a way that the letter or the abbreviation representing the variable is always listed first, such as P, and then you have your E followed by I. So that's the mathematical expression of path coefficient. So path coefficient is expressed as P and then E comma I, which means that the variables being influenced is listed first, and the one for the variable doing the influencing is listed as second. So if there is an independent variable that is considered as an endogenous variable because it has its own effect on another independent variable, so that is expressed as P and then capital P, and then you have a small letter E followed comma by I. So that's important to remember because later on it shows you the different values for P, which is the path coefficient represented by first independent variable E, and then another independent variable that may have an influence on the first independent variable represented by I. So path coefficient uses the standardized beta. So as what previous slides are mentioning, that this path analysis uses regression coefficients. So you will see the unstandardized and standardized beta coefficients again here in the output for path analysis. And then the standardized path coefficients are needed to determine the direct, indirect, and then the total effect. So this is where the path analysis goes above and beyond the traditional regression analysis, because now it is looking for the total effect of the independent variable. The use of the non-standardized coefficient makes it possible to evaluate how the magnitude of a particular path varies in different sample, in different subgroups, or different study populations. So it is actually a very good way of answering different angle of a research question when you use path analysis. So always remember that when we do path analysis, we either use the standardized beta or the non-standardized regression coefficient. The standardized coefficient, however, allows comparison of the magnitude of one path in the model with that of the other paths in the model to determine which of the independent variable has the greatest direct effect on the dependent variable. So the key word is the greatest direct effect is when you use standardized coefficient. Standardized path coefficient, which is path analysis coefficients, are needed to determine the direct, the indirect, and then the total effect of an independent variable. So there's a subtle difference here when you use the word standardized coefficient versus standardized path analysis coefficient. And then the use of the non-standardized coefficient makes it possible to evaluate how the magnitude of a particular path varies in different sample subgroups or study populations. So there's a very distinct function for standardized coefficient, and there's a very distinct function for the non-standardized coefficient when we use path analysis. So researchers wanted to identify predictors of individuals' perceptions of health. So this is an example now in the textbook. And then the independent variables are satisfaction with current weight, frequency of exercise, scores and inventory of personal attitudes about self, life, work, age, and education. First, the researcher used regression analysis to identify which variables were significantly related to the dependent variable of interest, which is satisfaction with current weight. Based on this, age, education were found to be not significant predictors of the outcome and were dropped. So this is the output. The first output in path analysis are correlations. So it's sort of give you the idea again that when we did the exploratory factor analysis, the first output of exploratory factor analysis is actually the correlation matrix. So here you see these commonalities in path analysis. It uses the correlation coefficients, and then you can see right away overall state of health, overall state 1:1 perfect correlation, because that's the way how it is. But when you look at overall state of health and exercise, it has a 0.39, and then overall state of health with correlation to the satisfaction with current weight, it's 0.369, and then it gives you the total, which is the 0.482. And then it moves to the second variable, and that is the exercise. Then it moves to the third variable, satisfaction with current weight. Then it moves to the next variable, personal attitude. And as you can see in this output, it looks at total effect. So it gives you total effect. And that is the key in path analysis. So here is the sort of what you call the theorized path that must be a priori. This is a requirement for path analysis. You as the researcher, you need to draw this path already before you conduct your research. This is a requirement in path analysis. And that satisfaction with current weight, personal attitudes, frequency of exercise has direct and indirect total effect to the overall state of health. And it cannot be circular. That's why it's called a recursive model, which means that the arrow, none of this arrow can go back in circle. So once you already have your dependent variable as overall state of health, you cannot put an arrow pointing back to frequency of exercise, or one of the arrow pointing back to personal attitude, or one of the arrow pointing back to satisfaction with current weight. It is unidirectional. It is recursive model, which is, as I've already mentioned earlier, I looked it up in the dictionary. Recursive means circular, but here in statistical term, recursive actually means non-circular, that it cannot go back to where it started. So if we started with satisfaction with current weight leading to overall state of health, you cannot go back again overall state of health and then put some arrow going back to your independent variable. It cannot be that way. So that is what path analysis is all about. So you have three independent variables here: satisfaction with current weight, personal attitude, and then frequency of exercise. They have directional arrow. It's cause and effect. It means it has temporal ordering. It means that it's non-spurious, that you've already accounted all potential confounding variables, that you have a very good understanding of this latent variable, which is overall state of health, and that you've already accounted all of the independent variable because you have a very thorough understanding of the phenomenon, and that you already measure all of these independent variables, and now you are looking at the indirect, the direct, and the total effect of each independent variable, and then you are going to examine the magnitude of the direct effect of each independent variable, because that is what path analysis is all about. It's going to give you the magnitude. What is the total effect of that particular independent variable in terms of cause and effect leading to the outcome, which is your dependent variable. So when you do path analysis, you need to run 3 regression models. Number 1, the first regression model is the overall state of health as the dependent variable with current weight, frequency of exercise, and personal attitude as independent variable. The second regression model will be a frequency of exercise as the dependent variable and personal attitude as the independent variable. And then the third regression model is the satisfaction with current weight as the dependent variable and frequency of exercise and personal attitude as the independent variable. So these are simultaneously done in order to get your endogenous variable, which is overall state of health. And so here you have your standardized coefficient, unstandardized coefficient. This looks very familiar. This is the output that we typically see in multivariate regression modeling. So you have there the constant, you have there the independent variable, exercise, personal attitudes, and then the current weight, and then the satisfaction with current weight. Those are the 3 independent variables that you are looking for, and you are examining the total effect that leads to overall state of health, which is your dependent variable, or what we call the outcome variable. So here, these are the different iterations of the 3 regression models that are being conducted when you do path analysis. And it gives you this unstandardized and standardized coefficient. And basically, the standardized and unstandardized, now it shows you P is the path analysis coefficient. And then O is the observe, and then you got all the different combinations here of the different path coefficients, and it gives you the different magnitude of that particular independent variable. So it has a very specific logic, and I will show you here, because these are now, I think I've already beaten this concept of direct and indirect and total effect. So I just wanted to show to you now the amazing mathematical logic behind a path analysis. Look how complex this, but again, we now have infinite ability, infinite computing ability because of computers. So we can definitely do path analysis without sweating. Can you imagine without computers? I can't. So these are the PhDs way back in the 1960s who actually plugged this into a software. And so this is it. This gives you the direct, the indirect, and then you have the total effect. And that's what path analysis is all about. Direct, indirect, total effects, and it gives you the magnitude of a particular independent variable in a cause and effect modeling. It's a causal model. So in conclusion, based on the output, personal attitude appears to have the greatest effect, because this is what path analysis will tell you. It's the magnitude. Which of this independent variable has the greatest effect on the dependent variable, which is your overall state of health. And in this example, it's the personal attitude because it was 0.48. And also, all but one of the sums of the total effect, a non-causal component, That's my 10-minute warning. Wow, we're really done with a quarter. 10 minutes. Sorry, that's my Emma. We are now in our last 10 minutes of stretch for the quarter. And you're all, Emma, sorry about that. So this is it. You're going to be done with statistics 2, and you're all going to be the future PhDs of the Philippines, and you're going to lead the country. So here we go. All but one of the sums of the total effect and non-causal components match the magnitude of the respective correlation coefficient, and that the one sum that does not, which is the satisfaction with current weight, is very close, within the 0.01. Let's go up here. So this is a satisfaction with current weight. So satisfaction with current weight, 0.01 is the total effect. So, but here your personal attitude is 0.48, and that has, in conclusion, that has the greatest effect, or the most, or the strongest in terms of magnitude in cause and effect modeling of what would lead to overall state of health. So it's all in the minds. It's all about attitude. That's what they say. Your overall state, according to this example, it's your personal attitude in life that has the greatest effect on your overall state of health. Assuming that all of our measurements of all these latent variables are all at the interval scale. So this is the limitations of path modeling. Consider whether any of the relationships in the model may be spurious or erratic. It violates the third condition of causation, which means that we have not accounted for other possible confounding variables that we should have included. So that's a limitation of path modeling. That's why you need to do your homework as a scientist. You need to do a comprehensive literature review, and you need to really make sure that your model, your path analysis model, accounts for what you're supposed to account for, so that you don't violate the third condition of causation. And then keep in mind that the need to replicate this model always with longitudinal data, because that is the second condition of cause and effect, and that is what we call temporal ordering. And that the other limitation of the path modeling is, can we assume that there is no or minimal measurement error in our measures? Well, always remember that for social sciences right now, we do have these limitations. All right, so that's it. Congratulations, everyone.
Thank you very much, Doc.
Thank you, Dr. Tarima.
We hope we will be able to answer our exams very well.
Thank you, Doc.
You will. All right. So,
thank you, Doc.
umana atong quarter. Wow, amazing. Iniguli na kog July. I have to call some of you doctor na ha. Who's graduating this Marso or April man ang graduate, or June man?
Yes.
Si bu doctors. Kinsa may mauna tawag na akong doktor sa inyo hatanan.
Who knows?
Magdungan mo tanan? Wow. All right. Mag-comprehensive na mo for this summer. All right. Well, good luck. Good luck. Good luck. Nemesis now is my role model. You are all in good hands, because your role model is Madam Cisno. It's amazing foundation for me. So, all right, you take good care, and I'll see you in the Philippines. I will be home actually middle of July because one of my cousins is getting married. So I'll definitely say hi to all of you, and I hope to see you all in my visit to Cebu Doctors in mid-July. All right, bye.
Thank you very much.
Bye, Dr. Tarima.
Bye-bye.
Thank you.
Thank you, Dr. Tariman.
You're very welcome.
See you, Doc.
See you.